Ever thought about testing your AI application for accuracy and precision, but could not quite identify the tools to verify your findings? Well, today on our show, Alon Bochman, who is my guest, has had the exact same problem while working with both Microsoft and Google's AI teams. Well, hello once again to our loyal listeners, and welcome to our 2025 season of the AIP podcast. My name is Anne, your host on behalf of the AI Partnerships Corp, and today my guest, Alon, has spent the last 20 years in data and machine learning out of a 30-year career in web and tech, while leading teams in AI in Azure and Google Ads. Alon constantly wondered why testing wasn't something that was prioritized. Well, as it turns out, testing wasn't a priority simply because it was both expensive and literally there were no tools that existed for testing AI applications. And therefore, we've come to the birth of RagMetrics, which came about to solve such a problem, helping more AI proofs of concepts or POCs make it straight into the world of production. In a world where the graves of AI things to come line the roads of good intention, Alon, it is so good to have you on the show with us today.
Thank you, Anne. It's my favorite thing to talk about.
Let's dive right in, Alon. Tell us a little bit about your backstory and why you founded RagMetrics.
Of course. I've been, as you mentioned, I've been doing AI for a long time, 20 plus years. My last role was head of AI for a company called FactSet. I joined them after Google, and FactSet is a Fortune 500 company based in Connecticut. They compete with Bloomberg. They sell market data, financial data. And I had a pretty big department there. I had about 60 engineers, product managers, etc. We had 100 plus LLM use cases, which is a lot. Everybody was excited about AI. Everybody wanted a use case, and nobody was testing anything. It was really frustrating, scary, upsetting. It's think of it like if you're a bridge building engineer and you have to build a bridge and you can't run any trucks on it. You just have to see what happens when the first person steps on. It's pretty scary, right? So that's kind of what it felt like. And we tried a lot of different things to get tests to happen. We tried to build a tool ourselves. We tried very hard to buy a tool. I even gave the team a blank check and a list of companies to shop from. And I realized that I wasn't alone. I called a few friends. I have some good friends that are doing pretty well in AI, and everybody kind of shrugged and said, evals are hard. What are you gonna do? And so then that was like sort of waving a red flag in front of me. I'm like, I think I could do something. And that's what RagMetrics is. We're trying to sort of make it just a couple of orders of magnitude easier with tools that are ready out of the box.
I'll admit, in my past life, so many of us just dive right into developing AI applications without testing them. And that probably leads to a whole bunch of hallucination. Tell us a little bit about how your solution works.
Absolutely. I think in the first generation of chat applications, AI applications, we're just so excited that AI can keep the grammar straight that we don't expect anything else. And a lot of the early applications don't really ask much of AI. Like it's just maybe it's write a poem with where every line starts with an A, or maybe it's count the R's in strawberry. It's basically parlor tricks, right? And it's like watching a dog play piano. We're so excited that it can get a couple of notes out. But now it's time to actually enjoy some music. So when you want to do something serious, something in the enterprise, it's not enough. It's not funny when AI just mixes something up, sends the wrong message to a customer, misinterprets a policy. And we've all heard these horror stories. Like there was this lawyer who brought a case that was completely hallucinated and tried to argue from that case. That lawyer had a really bad day. There was a Chevy dealer somewhere, I think in the Midwest, that sold a Chevy Tahoe for $1. That's a $78,000 car. That's before the tariffs. That's how much the car was. And it would get sold for $1 because the chatbot got hacked basically by a user. The user, and then that deal got upheld by a court. So there's like a lot of ways they could really, like you said, graveyards. There's a lot of careers and applications that can really end prematurely when they're not when software is not tested. So the way that our software works is it's a one-stop shop. So there's like I don't think we have enough time to go through all the features, but I'll try to keep it at a very high level. You have one experience that you go through as you're developing, and another one when you're in production. When you're developing, you run experiments. Experiments are like A/B tests. They help you make decisions that are data driven about every aspect of your code. And when you are in production, it's all about processing the incoming stream of conversations that the Copilot is having with your users and evaluating them by both humans and by an LLM judge. And the humans and the LLM judge make each other better by reviewing each other's scores. So that's the shortest way that I can explain it.
That's amazing. You just mentioned the judge. So you've also mentioned to me in our pre-show that RagMetrics has three solutions: the library, synthetic, data generator, as well as the judge. But I'm sure everybody's just dying to ask you about the judge. Tell us more about how the judge judges.
Of course. Everybody has this dream that we can offload our work to an automated little minion helper. And a lot of the work in testing AI applications is just reading what the model says and deciding if it's good or bad. And figuring out if it's good or bad is a very, it's not personal if we're talking about it in the sense of the enterprise, but it's very different from one business to another. Like, if we're dealing with a copilot that is a compliance copilot, then the judgments we want are very different than if it's a personal injury law firm, for example, right? They're going to have, even though the domain might be very similar, they have very different views and very different best practices. A secret sauce is different. So to make a judge work, it's really important to make the judge an expert in the domain and an expert in your business, so that the judgment is appropriate for you and your application. And that expertise is not available out of the box with ChatGPT or with Gemini or with any of those models. It can only be acquired as the application and the judge interacts with your domain experts and your users. And so the judge learns just like we learn by from constant feedback and course corrections. And so our goal is to make sure that the performance of the judge improves over time based on that feedback. So in the beginning, it might be no better than an intern, and over time, it becomes the partner, the managing director.
That's amazing. You've also mentioned that you've incorporated the use of agentic AI in the solution. The term agentic AI has become a buzzword in the world of AI recently. What do you think will be the next evolution of AI?
Yeah, it's a really good question. I'm so bullish and excited about AI. Obviously, I'm biased. I dedicated my life to it, but um, there have been so many discoveries made, in my opinion, in the last 3 years that even if we do nothing else but scale what we already know, we're going to reach something that's massively consequential for our civilization in the sense of like changing societies, changing the nature of work, changing economics for the average person, massively for the better, in my opinion. And that assumes no further breakthroughs in fundamental science, just taking what we know and doing more of it. More compute, more inference time compute, um, basically, more interactions, more training, more reinforcement learning, all things that we know how to do, just doing more of them. So I'm pretty excited about just that. But beyond that, there's we're just at the tip of the iceberg. I think there are if you dig into the way these models are built, um, it's incredibly inefficient, incredibly redundant. If you just look at the linear algebra that goes into training a model, think of millions of calculations that are each 99% identical with each other. And there's just like a little tiny difference, and you keep changing that difference, redoing. So you're redoing calculation that has, let's say, 1,000 steps, and you change 2 of those steps, and you redo the calculation over and over again, millions of times. That's kind of the way a lot of the training works and a lot of the inference works. And when you look at it, if you just take a couple steps back, there must be ways to do that calculation that are millions of times more efficient, where you're just not redoing almost the same calculation over and over again. It's just that we don't know how to do that. I mean, our brain knows how to do that. Our brain works with, what is it, like 3 watts of energy, and it can do all of these calculations, and the size of this. And we are currently trying to match some of that capacity with massive um, data center size computers. But we know that it's possible to compress all of that and to use a small fraction of the energy and to actually get a lot more done. We know because we have the machinery in our heads to do it. We just don't understand it yet. I think we will. So I think that I'm really excited about breakthroughs applying what we know to some new domains, AI creating science, AI solving medical problems, drug discovery. I'm really excited about agents replacing labor because I think it would mean that, I mean, I think it would mean that things become massively cheaper, and the average person can afford to live like a king because they can be all the things that we today can't afford because they're only done by very specialized people would suddenly be available, plentiful, cheap, fast. So yeah, I'm excited about those things for starters.
That's amazing. One for the road. We're quickly running out of time. Talk us through your solution and the success stories that you've enjoyed.
Yeah, absolutely. Let me tell you one since we're short on time. One of our earliest clients is a company that's building AI for accounting. It's a company called Tellen, Tellen, Tellen AI. And when we met Tellen, they had a couple of problems. They've been working on their app for about 6 months or so, and the first problem was that their first design partner didn't want to go live because they didn't trust that the app was actually good at accounting, at a particular specific accounting task that they were working on. And the conversation went along the lines of, Tellen told them, well, here's proof that it's good at accounting. Here's an example of an accounting question that it answers very well. And the customer said, well, how do I know if that's the only one? Maybe you cherry picked it. And so they kind of went back and forth like that. We created for them a benchmark that measures domain expertise in the specific accounting task that they were building. And we measured them versus all the free alternatives. And we showed with some quantitative rigor just how much better they were. And they were significantly better. Within a couple of weeks, their design partner went live. And within a couple of months, they were able to raise a $3 million seed round. So numbers matter. Investors care about it. Customers care about it. And if you put in the extra effort, people will notice.
That's amazing. Well, Alan, that's been a blast, but of course, that's all the time we seem to have for our show today. Very keen to track your progress through your development and growth. Thank you for giving AI companies such an easy to use tool to test their applications, a much needed solution. Once again, to our audience, this is Anne, the host of the AIP podcast, and my guest is Alon Bochman of RagMetrics. Thank you for tuning in, and to all our listeners, remember to like, share, and follow this episode with your friends and your peers.
Thank you, Anne.